Thank you everyone for coming here. Today we're going to talk about how to win at monetizing games as a service. I am Mike Nadal. I'm a data and analytics specialist working at Google Cloud. I work with a number of different game studios on issues just like this, as well as everything else that's data analytics. And I'm also here with Ari Wolf.
Hi everyone, my name is Ari Wolf. I'm a machine learning solution specialist on the Google Cloud for Games team. So essentially my role is to help customers better use Vertex AI, which is our AI and ML suite made available in the cloud.
Cool. So before we get too much further into this, a couple quick housekeeping notes. Please make sure to turn off all of your potential noisemakers. That's kind of first and foremost. Second, we'll remind you at the very end, but if you could fill out the survey, provide any feedback, that would be fantastic. Third is if this isn't the talk that you're here for, it is way too awkward to get up and leave now, so sorry, you're stuck here. With that, I think we can go ahead and dive in. So here are the goals for today. We knocked out the introductions, good to go there. Second thing we're going to talk about is the first thing that anybody ever taught me about machine learning was you got to have your data solution figured out. Garbage in, garbage out. And so the first thing we want to cover off on is how to unify your data and make the most of that. Next thing we're going to dive into, and this is where Ari is going to take over, is how to start integrating machine learning into all of your monetization strategies and what that looks like, specifically in Google Cloud. And then last but certainly not least, we'll save time for questions. If you're brave enough to ask questions here, we were more than happy to answer them as well, but we'll also be here throughout the conference and then also directly after the talk if there are things you want to ask us specifically. This is the one slide. So if you happen to doze off throughout the rest of the talk, or if there's some other things that distract you, this is the one slide that you manage to ingest, we're going to be happy. So the key takeaways that we'll start on, I'll do the first two since they're more data specific. This one's always tough for me, but you have to focus on data governance. And I say it's tough because I know that it's really hard and also extremely boring. So, but being able to build that data-driven culture, being able to make it easy to stick to that data-driven culture is absolutely key to a number of different goals that you'd like to accomplish using that data. So not only monetization, but anything else that happens to fall under the realm of data analytics. The second thing is start small, but think big. And what this really entails is a lot of times when you are looking to tackle these problems, there's a lot of siloed data that you have to de-silo. There are a lot of teams and politics that you have to play towards in order to start accomplishing the goals that you have set out to accomplish. Start small by picking like a select number of data sets and validating your idea. And once you have that, flesh out what the production level version of that use case is going to look like. And with that, I'll hand it over to Ari for the next three.
Great. Yeah, so in the second half of the session, we're going to discuss how you can leverage ML to enhance monetization. So we're going to focus on some foundational ML use cases that we feel like any practitioner should have in their toolkit. We also don't believe in building models for the sake of building models. Models are meant to be put into production and actioned upon. So we'll talk about some activation scenarios on how you can leverage these model outputs. And then finally, we'll wrap up the session talking about how you can evolve your ML strategy over time with automation. And then briefly touch on quantifying business impact with A/B experiments.
Fantastic. So let's dive into what it means to unify your data. So when we think about the experience of developing live games or games as a service these days, a lot of it has evolved into what we see here, where it's more than just making the actual game itself, which is already hard enough, but needing to figure out how to develop a long-term relationship focus with your customers, being able to target that relationship with the right advertising, the right in-game offers, being able to enhance or augment the gameplay itself based on the signals that those customers are sending to you. And in order to do really any of the things that you see up here, you need to have a good grasp of data. And what we've found working with a number of different studios is that they're actually producing all of this data. They have more data than they can really stomach at this point. And so once they have that actual data itself, what they start to figure out is, okay, we need to figure out in this slide, essentially, what's the difference between the first-party data that I have and the third-party data that I have, and how do I take that to start tackling some of the use cases I'd like to focus on? So from left to right here, real-time game experiences. So this one's going to be a little bit more complex, but again, once you get a handle on things like operational data, game data telemetry itself, and if you're able to start integrating that with some of the third-party data that things like Google provides or Apple provides, even Meta provides, then that's when you're able to start getting a better understanding of what are some timely in-game offers that I can make to my players based on the data that they're sending to us, either based on how they're playing the game itself or offers that they are accepting or rejecting. Once you have a solid understanding of how your players are engaging, that's when you can start moving into improving retention and monetization. So a lot of the focus is initially on, okay, first, is my game good enough that players are willing to play it? Am I getting the signals at all? First hurdle to clear. But then once you do, start to understand what's making your customers stick around, what's making them leave, and being able to build on top of that with built-in recommendations. So we'll talk a little bit about how that looks in just the world of data analytics, and then evolve on that a little bit more with AI and ML itself. These next two are where the idea of data governance really starts to come into play. Being able to share that data across the organization is really what makes these use cases into something that is much more impactful to the studio itself. So while each individual team might have their own perspective on how to operate and function in the world of their known data sets, being able to take those data sets and merge them across team wherever it makes sense is really where we start to see the most benefit gained from all of the data collaboration that you can put into place. Now, the important part about being able to tackle that is being able to do so while protecting user data and operating with trust. The second that either there's a user data leak or there's improper PII handling that happens within your organization, that's a killer. Every data analytics proposal that you put into place from that point forward is going to have a little cloud over it, and that's what we want to try to avoid. So once you're able to tackle all of those things, the comprehensive insight that you're able to gain from first and third-party data is what's going to build the most success towards tackling the games in today's environment. So this is kind of what the current set of silos tends to look like at any given studio. Whether you're in marketing, revenue, or in operations, you're going to have different goals that you are tasked with accomplishing. And sometimes those align, sometimes they don't really. But for us, what we'd like to be able to do, and you've probably seen a slide like this before, either directly from Google or a number of other vendors, what we want to emphasize here is that while those silos do exist, we don't necessarily, when we say desilo, we don't necessarily mean that you need to take every bit of data and put it all into one database or one data warehouse. What we'd like to emphasize as part of the solutions that we'll talk about in just a second is develop a metadata understanding of that data, where it lives, who has access to it, and who should have access to it. And once you do that, breaking down the silos that exist between those teams is really just a matter of getting the right permissions to access that data. The benefit of being able to do that is once those silos are broken down a little bit from that metadata perspective, tackling all the various use cases that are critical to each one of those teams becomes much more simple. But then more advanced use cases, such as dynamically changing gameplay experience or dynamically offering based on recommendations, start to become much more viable as well. And so with that, super quickly, we should define how Google thinks of data governance itself, since it's kind of a loaded phrase. And as you stated a little bit earlier, it might not be the most fun, but you can kind of think about it like, hey, I need to collect all three of the data governance jewels, and I'm on a quest to do so. Still kind of boring, but that's okay. So the main three things that we think about are data security, data quality, and data compliance. So if you're able to, what I would say is focus on a charter, the culture of data governance, before you start to dive into what technology is going to help me tackle data governance. If you start from technology and focus on that as your data governance solution, you're going to run into a lot of issues. You're probably going to fail, to be honest, because you are instantly limited by the capabilities of that technology itself. Whereas if you have a charter that the company can agree on, that you all can stick to, no matter what technology you use, then you're in a much stronger position because you can fit that technology to your need. And for us, it's being able to understand, again, who has access to the data that is currently available to your company. Security also entails what people are doing with that data. There have been a number of customers that we've worked with that have told us, we found a data pipeline that was spun up. We don't really know who spun it up, but it is porting out customer data. And we just hope that that's something that is coming from inside of our studio. And we want to avoid that. So the next is data quality. So again, that whole concept of garbage in, garbage out is centered around what tool sets are available in order to make things like standardization, data lifecycles that much easier to work with. And easier is a very key point there, because the harder that you make it to follow the guidelines that you lay out in your data governance charter, the easier it's going to be for people to kind of try to bypass it or just get their day job done. So being able to automate a lot of the data quality issues that people run into is going to be foundational to making sure that the data governance plan that you create is something that you can stick to. Last but not least, data compliance. There are a number of compliance regulations that we as we in the gaming vertical have to start thinking about, whether it's GDPR or really any other compliance standard that's out there. Being able to audit and classify data and ensure that when you are operating on that data, if you have an idea in mind that the data that you're looking at is something that is clean and it contains data that you're supposed to be looking at, is paramount. So once we're able to kind of handle all three of those, and if you have a game plan for tackling those three, you're going to be in a pretty good place. And that's something that you shouldn't necessarily create one draft of and then you're done. As you release that draft and start to iterate on it, work with it within your studio, you'll start to understand what parts do we need to change and what pieces of technology would actually make sense to add in order to benefit the game plan that you set out here. So with that, it's time to dive into a super complex data architecture. Not really, though. It's, for the most part, when you're tackling all of these problems in GCP, it's just BigQuery. What started out as really just a simple data warehouse is actually started to evolve into a data platform. And so a lot of the use cases that we've talked about so far are things that you can actually accomplish purely using BigQuery. There are definitely more advanced versions of data architectures that you can put into place when you're operating in BigQuery. But again, if you remember that second point, start small, think big. What we see people use BigQuery for a lot is prototyping ideas for other teams to take and advance in much more complicated fashions. But what we want to be able to do is empower people with some of the more basic things that you can do with just SQL, with just the UIs that are built into BigQuery itself, and running with that. So what we're going to do is start at the top and kind of work our way clockwise and try to get an understanding of how each one of these systems works with BigQuery. And then what we'll do is we'll dive into those in individual slides so we can get a better understanding of kind of what that looks like. So from the top, marketing campaigns and revenue data, a lot of just purely built-in connectors that work directly with BigQuery. So if you're looking to port in marketing data, if you have CRM data, that is important to better understanding what your player is doing, where they're doing it, and how you can message back to them. All of that can happen just directly via built-in connectors in BigQuery. Operational data, I think, is particularly important, something that is near and dear to my heart. What that usually ends up meaning is creating streaming data pipelines. And the cool thing about BigQuery is whether you want to batch or stream data in, you can make that happen without having to necessarily use a different system. We are going to talk through what a version of that system would look like so that you can start making a lot more real-time decisions based on the signals that you are getting. Next, when you dive into things like machine learning and security and governance, machine learning is actually built directly into BigQuery. So with no more than 3 SQL queries, you can actually train your model, evaluate your model, and then actually implement the model itself so that you can save yourself some very expensive machine learning scientist hours. And if it's just an analytics idea that you want to put into place and validate, then that's something that you can start to tackle with BQML. The next thing is security and governance. And the key phrases that we want to jot down here are going to be Dataplex and BigLake. So we're going to come back to those ideas, but those are integrated directly into BigQuery. So when you have data that lives in BigQuery itself, but also data that can live in a number of other disparate systems, those are all things that you can have control over so that when people are running their marketing analytics or if they're doing in-game crash report analytics, whatever it may be, they have access to the right data sets. And if they need to get access to those other data sets, they have a means to be able to do that. Down here, where we have identified the individual teams themselves, marketing teams, revenue teams, and operations teams, those are delineations that you can make using Dataplex so that when a team is looking to interact with any data set that lives in BigQuery, they are already part of a given team that has its set rules and boundaries for how they interact with data. And those are things that you can control and evolve over time. Last is data sharing, both with partners, but then also across teams. So we have a tool set that we've developed that lives on top of BigQuery called Analytics Hub, which has really made data sharing within BigQuery that much easier. And so you'll notice with this and machine learning and security and governance, there's bidirectional arrows. And the purpose of that is we want to be able to have that be a relationship that shares data back and forth. So the data is constantly evolving. How you look at the use cases that you want to be able to tackle are all also something that you can kind of take into account as time goes by. These are all individual building blocks. Some of them you can take advantage of right out of the gate. Other ones you're going to set up over time. Some of them you may need now, and some of them you could do without, and that's totally fine. This is an example of putting everything together all in one basket. And what we'll do is dive into what each one of those individual building blocks looks like so that you can figure out, does this make sense for the use cases that I want to tackle? And if not, figure out where they fit in the future. So the first thing we'll dive into is game data telemetry. So operational data in particular, when we're trying to understand if there are exploits happening in our system, if there are game crashes that are happening, and we want to be able to action on those types of things. This is a fairly basic, but also pretty straightforward implementation of what that telemetry example would look like. So for us, there are 2 new technologies that we introduced here. We won't spend a ton of time on those because they each could be their own 1-hour presentation. But Dataflow is our managed version of Apache Beam, which is an open source tool for batch and stream. And what you're going to end up using that for is when you get that raw data in, there's a good chance that you're going to want to transform it. Maybe it's in proto format, it's nested, and you want to get it into row format for BigQuery, whatever it may be. There's window sessioning and aggregation that you can do in Dataflow, as well as data transformations that allow you to get data from point A to point B while transforming it along the way. PubSub is a system that we have for ingesting a number of small messages, really, at incredible speeds. And the most important thing about both of these is really that they are fully managed. So when you're starting to think about how we want to build out these style of pipelines, but you don't want to spend a ton of engineering hours on building them out, a lot of what people are building these days stems from being able to do so without having to manage the actual underlying infrastructure. So what we'll see here on the right is a live gameplay data source that's going to drop data into PubSub as purely an event collector. From there, you'll route that through Dataflow itself, and from Dataflow, you can determine which one of the topics that are located in PubSub does it make sense to land this data in. Is the use case something that's more so centered around real-time alerting? Are you looking to to port that data out to some third-party services that are dependent on it? Do you want to land that data directly in BigQuery, or really any other data sync that you could possibly think of? That's what this style of system is going to be able to accomplish. So that's how we end up tackling operational data. That can be a fundamental part of understanding what it looks like to take that data, make the most of it. And from there, what we can start to dive into as well is what the BigLake and Dataplex integration looks like in BigQuery. So these were the two that we wanted you to hold on to for a little bit while we dive into what they actually look like. So Dataplex itself is a user interface that is built into BigQuery, and it's going to be much more focused on understanding your data from a metadata layer. So there's things like auto discovery, security and governance that you can put into place. You can slice and dice your data in a number of different ways that are pertinent to the actual teams themselves. So in creating one of the newer catchphrases that we have called a data mesh, that's where we start to focus more so on how do we distribute this data based on the teams that it's important to versus just creating a purely like bronze, silver, and gold version of the data. So the other cool things that you can start to dive into with Dataplex are things like data lifecycle management. So when you look into archival data and understanding when it makes sense to move something into archival data, or if you want to automate data quality tasks, like better understanding if there should or should not be null values, if there are expected values that you can start to tackle, then those are all things that you can start to automate with Dataplex itself. BigLake is when we start to dive into a lot more of the data governance implementation of all of the data that we've discussed so far. So being able to implement things like fine-grained access control, which is in particular row and column level security. So when people are, again, operating on data and they just run a query, they'll know that the data that they get back is something that they're supposed to be looking at. It's already safe and secure, you're good to go. There are a number of other benefits wherever you see fit. So when you want to start optimizing for asset transactions, being able to write faster. Again, things that are much more advanced implementations of your use case once you validate your initial idea. The other benefit of really all of these systems is that whether your data is structured, semi-structured, even unstructured, if it lives in Google Cloud, if it lives in another third-party provider, if it lives on-prem, there are another number of different ways that this API implementation can access that data and give you that understanding of that data, really no matter where it lives. Because what we'd like to have you do is, again, first, instead of building out a data pipeline that's going to migrate that data directly into BigQuery and then working on it there, validate the idea first, then build the data pipeline, save yourself some time and effort. Last thing we want to dive into as we start to piece together what all of the individual blocks look like is the Analytics Hub architecture. So Analytics Hub is going to be the version of tool sets that we've put into place that allow you to share data not only across your organization, but also to third-party services. So when we think about how do you monetize the data that we're generating itself, this is also what we can start to put into place. And so the architecture that we see here, Analytics Hub is going to be in the middle. You will have the data publisher itself, so that's going to be the team that actually generates the data. And then from there, what you're going to have is a data subscriber. So they're going to be able to search the exchanges and listings that Analytics Hub makes available and see just kind of what data is out there. What data can I start to play with? And the cool thing is that this all works in tandem with things like Dataplex and BigLake, so that when you are searching through those exchanges and listings, you see the data that is most pertinent to you, and also data that you should be seeing and that you're able to operate on. And really the whole system is put into place so that it can make the original idea of sticking to the data governance charter that you put into place as easy as possible. This is a little bit of an eye chart. I hope that you have some megapixels on your camera, but happy to share this slide out with anybody that's interested as well. But this is just an example of being able to take all of this and piece it together to tackle something like customized gameplay. And so really the solution here is taking your data sets, whether that's things like current and past inventory of your game players, or instances of purchases that they've made, storing that in your data warehouse, but then also being able to operate on it and create multiple segments based on those players. Are they high skill but low spenders? Are they low skill but high spenders? That would be me. And once you have those segments, what do you use, or how do you start to optimize towards the type of recommendations that you'd like to build out with them? So are there recommended builds that you'd like them to tackle? Are there quests that you should highlight and quests that you should deprioritize based on the play styles that they have? Are there offers that you've sent out in the store itself that may not have landed with that particular user? And are there new ones that you can then start to showcase to them as well? All of that you can actually tackle just using the tools that we've talked about so far. Once we start to dive into things like Vertex AI, which Ari is going to talk about in just a little bit, you can start to see how to make those that much more advanced. Once you have an idea of all of these tool sets that you'd like to be able to piece together, you can start to really not only handle the basics, some of the things that we see up here, some of the things that you're probably tasked with today, either optimizing market spend or getting to users before they churn, but then you can also start diving into some of your more advanced use cases like customizing gameplay. And to really put this into a more concrete fashion, I usually don't like these kind of slides where it's fairly salesy. Here's a customer that obviously they doubled their click-through rate and half their costs in order to do so. Sounds fantastic, but really for me the most important thing here is two things. The first is the quote on the right, and that Google was able to help us build this solution. And this is important because what we're not selling you is big game monetization. It is a series of tool sets that you can use to best implement what this solution looks like for you. And what we'd love to be able to do is work together with your studios to best tailor the solutions that we have to the problems that you're trying to solve. The second thing is, if you're interested in learning more about how Square Enix themselves have actually tackled this problem and implemented what this unified data platform looks like, they are giving a talk later on today in this very room. I think it's at 2:10 to 2:40, and they'll walk you through what that implementation looked like. And with that, I will hand it off to good friend here, Ari, and we'll talk some more ML.
Awesome. Great. So we wanted to kick off this section on enhancing monetization with ML with a quote from Professor Peter Fader. So it basically says, if you can't sort out your customers, if you can't look at them and know who's good, who's bad, then you can't be player-centric or customer-centric. So what I really like about this quote is that it really gets to the heart of how machine learning can aid your monetization efforts, because it can really help you understand, which customers or players do I really need to focus on, and potentially which customers should I avoid or deprioritize in a lot of cases. So machine learning can enhance monetization in a few different ways that we'll walk through throughout the presentation. The first one is to increase player acquisition. So essentially, you can leverage machine learning to get a better sense for players who are more likely to buy, install, subscribe, and essentially reach those prospects with ads to incentivize them to take that action. Another potential application of machine learning is to better manage your ad inventory. So machine learning is a great way to better understand who should receive an ad. Should I save an ad slot for myself, or should I potentially sell that ad slot to an advertiser if you're a publisher in this case? Mike touched on churn to a certain extent. So machine learning is a really great way to understand which customers are on the verge of lapsing. So it's a common use case. I think it's one use case that most people are familiar with, but it's something that you should definitely lean into out of the gate. You can leverage recommendation systems and custom segmentations to enhance personalization. So that's another use case that we'll dive into in a bit. And then one lesser use case that I feel like is often overlooked is leveraging machine learning to increase CPMs. So again, this is tailored towards a publisher in this case, but you can often use curated audiences. Google has their own proprietary audiences that they sell to allow your advertisers to target those audiences, and you could get an increased CPM in that case. So it's directly enhancing your revenue and your monetization strategy. So we will start off with the base use case of predicting churn. So one persistent problem that a lot of gaming companies face is that there is a lot of games, there's increased competition. In a lot of cases, gaming companies are vying for players' attention, and attention and retention has become a problem. So one stat that we often see across gaming companies is that gaming companies only see a 25% retention rate for users after the first day. So obviously that's not very high. Lapsing is a persistent problem that we want to keep in check. So one approach that a lot of gaming companies face is combining their behavioral data with their demographic data to build models that are going to indicate or predict which players are on the cusp of lapsing within the first 24 hours so that you can have some sort of intervention, whether that be a promotion or some sort of offer, so that hopefully you can keep those players as a customer. So another challenge that gaming companies face is sorting through, the myriad number of players that they're working with and trying to understand who are the really high value players and who are the low value players, and who should I deprioritize and who should I really spend a lot of time on. So you might ask yourself, why should I lean into predictive lifetime value modeling? And I really find these two figures or data nuggets really impactful. It's actually 5 times more expensive to acquire a new player than an existing player. So really maintaining your current player base is of utmost importance. And then oftentimes when we do predictive lifetime value modeling, we find that it's a certain subset of your player base that's generating a lot of your revenue. So time and time again, we see this same statistic or benchmark, but oftentimes 20% of your players are accounting for upwards of 80% of your revenue. So really sifting through that consignment bin of players and figuring out who's high value and who's low value is really important. So I'm not really into figures and different diagrams, but I actually do really like this diagram on the right-hand side of the screen. It basically showcases if you treat all of your players the same, you're actually leaving a lot of money on the table. So by treating all of your players the same, you're likely underinvesting in your highest value players, which is the 2 bars that you would see on the left-hand side, and you're overinvesting in your low value players, which is the 2 bars that you see on the right-hand side. So we know that players aren't created equal, so predictive lifetime value is a good way to understand who to spend time on and who not to spend time on. So let's bring this to life a little bit. We said that we don't want to build models for the sake of building models, so we're going to walk you through several actionable steps that you can take, or activation scenarios, which is what we like to call them. But you can essentially use machine learning to improve the return on investment of your player acquisition efforts with modeled audiences. So here's an example of how this might work. So essentially, you could build a model based off of in-app event level data. Because we're Google, we just used one of our MarTech tools. So GA360 is a MarTech tool that we're using in this case. So let's say we build a model based off of the signals within that app analytics tool. We can then import those predictions and set up a workflow or a pipeline to bring those model outputs or model scores back into your MarTech tool. And what that allows you to do is, within the MarTech tool itself, create segments that you can then pass to different ad buying platforms. This is very Google-centric, but this is possible outside of Google as well. But this would essentially allow you to pass modeled audience lists to a display and video 360 or a Google Ads, so that you can target or reach those users with media in order to retain them. So one question you're probably asking, is this possible with game telemetry data? This same thing is possible with game telemetry data. You could also build these same models off that type of data set. I will call out that the way that you would activate is slightly different, so you wouldn't have the same workflow that we have up on the screen. But a lot of media partners, whether that be Facebook or Google, you can send them custom lists that you can onboard into these buying platforms on the right-hand side, which allows you to reach those audiences with ads. So another activation scenario or way that you can action off model outputs is by combining model outputs themselves. And actually, I'm fond of this activation scenario myself. So in this example, we've trained two different models. So we've trained a churn model and a predictive lifetime value model, which you see in the chart at the bottom left-hand corner. And what we've done is we've essentially multiplied the two values together. So if we look at the top row, we multiply 0.6 by 500 to get essentially a new metric, which we're calling expected value at risk, which again, looking at the first row is $300. And what I really like about this approach is it allows you to understand where to prioritize. So for example, if your cost to reach a customer, and when I say customer, I mean a player, if your cost to reach a player exceeds that of your expected value at risk, that's someone that you don't want to spend a lot of time on. Whereas if your expected value at risk greatly exceeds your cost to reach the customer, those are the people that you really want to lean into. And again, going through this metaphor of gaming companies are constantly going through this consignment bin of players and trying to figure out where to spend time. This is a good way to do that. So the next two use cases that we'll focus on are surrounding how to personalize the experience. So we'll talk through data-driven segmentation and recommendation systems. But personalization is very important, and time again, we see that personalization really enhances monetization. We actually see that customers are 40% more likely to spend more when they get some sort of curated or tailored experience. So it's something that customers at the end of the day have come to expect in a lot of cases. So this example is specific to a data-driven segmentation. So what we've done in this case is we've leveraged a clustering algorithm. There's a lot of different flavors or types of clustering algorithms, but we've essentially broken out our player base into 6 different cohorts. So essentially what that would allow us to do is after we've used the clustering algorithm, we've come up with our cohorts. You can then essentially profile those different clusters, and then based on what you learn from that profiling exercise, figure out how do you want to tailor that experience so that it resonates with the given player. So at Google, we always ask, why care? So why would you want to do this exercise? So in a lot of ways, it's going to increase retention and engagement. And it also really moves a lot of business metrics. So I feel like churn has been kind of a common theme throughout my talk so far. It helps to reduce churn. It really helps to not only improve engagement, but also increase your average revenue per user. So since this talk is focused on monetization, this is one approach that will really help to move the needle. So there's another way to tackle personalization, and it's via building a recommendation system. There's a lot of different ways to build a recommendation system, from matrix factorization to two-tower encoders. There's a lot of different flavors. But at its most basic level with the recommendation system, you leverage 2 different data sets. So you'll leverage an item catalog and you'll leverage event-level data. And after you've trained your recommendation system using those 2 base data sets, what it allows you to do is you can offer up a personalized item to every given user. So comparing the data-driven segmentation to the recommendation system, I would say the segmentation allows you to learn a little bit more about your players because you're going through this exercise of profiling them and understanding them. You don't have that same benefit from recommendation systems, but recommendation systems are impactful from a monetization and revenue perspective. So at Google Cloud, we have multiple flavors of recommendation systems, and we always see that it moves the needle when it comes to revenue. And we've seen up to a 50% lift in revenue and up to a 5% lift in total revenue per session. So it's really going to help enhance revenue within your organization. So going back to, what can I do with these model outputs? How can I activate? We wanted to walk you through some examples on how you could activate off of a data-driven segmentation. So we talked through one of these already, but one way to increase your CPMs if you're a publisher is to essentially sell these proprietary audiences for an increased CPM. Google actually does this themselves. Facebook does it as well. They basically offer up their own personal audiences that you can target at an additional cost. So that's one way to activate off of this type of scenario. The other way to leverage a data-driven segmentation is to use it to better decision your ads to given users. So in this case, you would use an ad management platform to say, based on what I know about this given cohort, I'm going to send them this specific creative because I know it's going to resonate with them because they like dog, cats, or whatever they care about. So wrapping up with the use cases, and then we'll walk into evolving your ML strategy. The final use case that we wanted to talk through is leveraging machine learning to predict some sort of outcome and enhance acquisition. So what we mean in that case is how can we leverage machine learning to predict someone's likelihood to install, subscribe, or buy? So there's a lot of different flavors of this. What's interesting about this use case is logistically, it's very similar to your churn model. The only thing that you're doing in this case is you're changing the outcome that you're trying to predict. So rather than trying to predict someone's likelihood of lapsing, we're trying to predict someone's likelihood to buy or install or subscribe. So your label is just changing in this case. So I'm actually really fond of this scenario as well. So the way that you can action off of these player acquisition models is using it to better manage your own ad inventory. So in this example, you would essentially onboard these segments into your ad management platform. And what I like about this example is you can learn just as much about a high likelihood as you can from a low likelihood. So the three segments that we have in this case is at the top, we have someone who is highly likely to install, subscribe, or buy. We have segment B, which is kind of middle of the road. They're somewhat likely to buy. And then segment C is someone who's really not going to, we don't think that they're going to buy, subscribe, or install. So the way that you would reach these segments can vary. So for the very first segment, segment A, we know that these users are likely to take the action that we want. They're going to convert anyways. So my position there is don't do anything at all. Don't spend a lot of time on these users because they're already primed to do what we're asking them to do. Where you'd want to spend your time is on segment B, so the somewhat likely to install audience. And that's where you can have some sort of intervention, whether that be an in-game offer, or some sort of action that's going to incentivize this specific segment to convert. And then finally, for audience segment C, because we know these users aren't going to install, subscribe, or buy, this is ad inventory or ad slots that you should set aside for a third party or an advertiser because they're not going to add a lot of value to your business. So you can set it aside for someone who's buying media from you. So moving into the next section on ML monetization strategy and measuring return, this will get a little product focused. We wanted to quickly introduce everyone to Vertex AI, but essentially the key takeaway of this section is in order to really evolve your ML strategy, you're going to want to lean into machine learning operations, automation, and then proving impact to your business is very important. Having those data nuggets to back up your efforts is important as well. So we'll also speak to how you can leverage A/B experiments to better measure return to your business. So Google is essentially, we're in love with machine learning. We live and breathe by it. So we want as many people as possible to leverage machine learning. So essentially what we've done is we've created these 3 prescriptive paths that customers can take so that hopefully we can meet every user where they are in their AI journey. So I'm going to go from left to right, which is out of the box, to custom or DIY. But the first path is essentially just leveraging pre-trained APIs. So you'll ping an endpoint, you'll get a response back. There's no training of a model that needs to be done, and you can easily get some sort of prediction and leverage it to your needs. The middle of the road path is something that Mike talked about in the earlier section, but we have what we call low-code or no-code solutions. So BigQuery machine learning is a SQL-based solution that's built into our data warehouse. You can iterate, experiment really quickly. AutoML is essentially a UI-based way to build out state-of-the-art models. So you don't necessarily need to be an ML engineer or a PhD level data scientist to leverage that middle of the road path. However, we know that gaming companies leverage machine learning day in and day out. So if you do have the ML engineers, if you do have the PhD level data scientists, we do have the tooling that you need to build your own custom models as well. So starting with the pre-trained APIs. So we have pre-trained APIs to address machine learning problems related to vision, language, conversation. So there's a lot of different flavors of these pre-trained APIs. We also have an AutoML counterpart to each pre-trained API. So if you want to use your own data in a low-code way, there's that option as well. But very easy to use. We maintain these models for you, so there's nothing that you need to do on your part. You just ask for a prediction back, and we send it to you. So this is a bit of an eyesore, but this is the 1,000-foot view of all the great things that fall under Vertex AI from a custom modeling standpoint. I'm not going to walk you through every single product that we have within the suite, but I can touch on a few of the foundational pieces, in my opinion. So Workbench is a key part of Vertex AI. Essentially, that is our Jupyter Notebook environment where you would train your own custom model or build your own machine learning pipeline. So that's definitely a key piece within the tool set. The other service that's important is our training service, which you can use to obviously train your models. Our prediction service can allow you to get predictions back in batch or an online scenario. So gaming companies typically care about real-time inference tasks. So we can definitely leverage our prediction service to do that. And then one other piece that we wanted to talk about, and we'll actually spend a little time on this, is Vertex AI pipelines. So we know that models are trained on a snapshot of time, in a snapshot in time, and we know that user behavior, or player behavior is going to change as well. So leveraging pipelines and machine learning pipelines to automate the retraining and monitoring of your models is definitely important as you evolve your ML strategy. So at Google Cloud, we love to do a lot of user research. So what was interesting is the product team who's developing Vertex AI, they did multiple studies. And essentially what they learned is that data scientists are building tons of models, they're experimenting, they're doing great work. But a lot of times that work is done in vain because those models never make it into production. So the stat that we've seen inside and out is that more than 87% of machine learning projects never make it into production. So our product teams went back to the drawing board and tried to figure out, how can we help these data scientists and these ML engineers actually action off these models that they're training. So previously, Vertex AI was known as the Cloud AI Platform. It received a facelift about 2 or 3 years ago, and there's a lot of advantages that came with this new and improved version of our AI platform. So like I was mentioning earlier, we added a lot of tooling to enhance machine learning operations. So it's very easy to lean into machine learning pipelines and retraining your models out of the gate. We unified the data and AI experience. So going back to what Mike was saying earlier, data and a data strategy is definitely foundational to doing AI well. So we wanted to make sure that our tooling made it that much easier for AI practitioners to tap into the data that they need to train their models. So there's unification there. We also talked about the 3 different ways that you can train models on cloud. So we have a custom solution, we have the low-code, no-code solutions, and we also have the pre-trained APIs. So with the new tooling, you also have a more centralized way to keep track of all these different models that are available within Vertex AI. And then the final thing that I'll talk about and just briefly touch on, we also released a lot of algorithms that were only previously used at Google for our own commercially facing products. So one example is Vizier. Vizier is a hyperparameter tuning service that we use for our own apps. We really believed in this service and we wanted to provide it to enterprises. So there's several algorithms that were internal to Google that are now available for customers to use out of the box. So a lot going on this slide, but I just wanted to highlight this slide in that all the pieces that we talked through in that 1,000-foot view of Vertex AI has a place and a home within a larger machine learning workflow. So at the end of the day, we do want practitioners and gaming companies to leverage each piece of Vertex AI if possible. So we want you to use our training service. We want you to house all of your different models within our model registry and deploy on our prediction service and monitor for training serving skew within our monitoring service as well. How are we doing on time? Good. So the next thing that we'll talk about is Vertex AI pipelines. So even if you are building a relatively straightforward model, so churn isn't necessarily the most advanced machine learning use case. It's very impactful, but I wouldn't say it's super advanced. But with even simple models, you want to retrain these models to make sure that they're performing well. You want to monitor them when they're in production to make sure that there's not a degradation in performance over time. So that's where Vertex AI pipelines becomes really important. So with Vertex AI pipelines, we support two common orchestrators that I'm sure a few people in this room have heard of. We support Kubeflow and TensorFlow Extended. If you are a machine learning shop that loves TensorFlow as a framework, TFX is a great option to leverage. We've seen that by and large, clients are leveraging Kubeflow to build out their machine learning pipeline. So it's really nice that we have multiple options from an orchestration standpoint. Vertex AI pipelines is very scalable. And what we mean by that is you can leverage and run as many pipelines as you want. It's cost effective in that you only pay for the resources that you use. And then there's additional benefits like metadata tracking. So as you run these machine learning pipelines, artifacts are going to be produced. And with the machine learning metadata store, it's really easy to backtrack within a pipeline to understand what might be causing issues or to help debug. All right, so I think we're actually to the final slide. So we wanted to briefly touch on experimentation. We're not going to belabor this too much, but in addition to leveraging machine learning to enhance monetization, you can use A/B experiments and experimentation to better quantify impact to someone's business. So this can take a lot of different forms. A/B experimentation itself is a very broad topic. But if we go back to some of the use cases that we were talking about earlier, recommendation systems being one, one way that this could work is you could leverage a testing platform to serve up a personalized experience to one set of users that has those recommendations embedded in it, and then have a more generic experience and serve that up to another set of users. You then compare the downstream impact on your business, and that's one way to quantify the impact of personalization and how that impacted monetization. The chart on the left-hand side shows an analysis that you can do after you do geo experiments, but that's another great way to leverage A/B experimentation. For those of you who aren't familiar, at its basic form with the geo experiment, what you do is divvy up geographical markets into test and control groups that are similar. You then will have some sort of intervention. So let's say we're trying to understand the impact of a promotion. You would then have that promotion within the test markets. You would hold out that intervention within your control markets and then quantify the downstream impact. So machine learning enhances monetization, but I feel like the A/B experiments can help add additional color to how you're driving business impact. So it's something to think through as you evolve over time. I think that's everything. So we'll start with any Q&A. So I'll open it up to the floor.
Yeah, back. Might have to journey forward a little bit.
5 minutes.
Yeah, right next to the projector there.
So when I got to where I am now, we had, data was obviously a mess to your point. It usually is, right? It's an 8-year-old game. We did a lot of work. We unified it. We cleaned it. We got marketing and in-game data together, right? So we're now back at a place where we can do machine learning, but because we did it, not with Google, we're not using your services. So my question is, if you already have a dedicated data setup, like a data stack with data governance and clean, trustable data that's all connected and not siloed, is it possible to use some of the tools that you mentioned for machine learning on top of things like Snowflake or AWS?
Yeah, so there's a decent amount of effort that we've put into the open source side of the house. So things like Apache Beam is like a version of being able to take some of the ideas that we have at Google, but then also use them in a number of different cloud providers or instances, whether that be Snowflake or Redshift, kind of whatever it may be. As well as some of our ML tools, things like Kubeflow are also open source. So some of the things that we see here are Google flavored, but a lot of the underlying technology itself is open source. So if you want to tackle a lot of these instances using different technologies, as long as the principles that you put into place are sound, the technology itself that you use implemented is not so
Awesome,
important.
thank you very much, fantastic. I don't know if you noticed me like shaking my head.
Yeah, well, no, to add additional color. So Mike and I are actually working on a project that's very similar to this. So like one approach that we're thinking through is, let's say you built a model in a different cloud. One approach could be, saving model artifacts within cloud storage in our case, and you could then use it to deploy that model on Google Cloud.
Okay,
So you don't necessarily need to be locked in, which is one advantage of Google Cloud.
that's awesome.
Yeah.
Thank you so much.
Yeah, my question's about like Firebase sort of does a lot of this user segmentation for pre-existing applications. So like, what does it look like to then connect this to BigQuery, which may be like another platform? You could have like overlapping user segmentations going on. How does that work?
For sure. So Firebase is another fantastic example of a technology that is built with the idea in mind of, from one platform, we'd like you to be able to tackle multiple different use cases. So usually where we see Firebase implemented is in the context of things like mobile gaming. But what we'll say is, since that's part of our overall strategy in order to work with and operate data, there are built-in connectors that can have you land that data in BigQuery so that if your use case starts to span outside of just the realm of what Firebase is capable of, you'd like to start tackling more advanced things, you can start diving into that with some of the built-in connectors that we have. But also Firebase itself, we're looking to try to evolve in its own capabilities. So stuff to handle there for sure.
Yeah, sorry, I wanted to ask, so when you were defining the users as good and bad, I was thinking if you consider anything, I don't know, from a different perspective, maybe from ethical considerations, or was just good user, high revenue, bad user, low revenue?
I see what you're saying. Yeah, so a lot of times when you're sorting through these different model outputs, a lot of times it's arbitrary. But one thing that I will say about Google Cloud is we really are focused on responsible AI. So this really kind of falls outside of the scope of this discussion today, but we do have tooling like explainable AI, model monitoring, which is meant to help you understand, out of all of your users, are the predictions equitable and not biased? So I would say that we do have a separate set of tooling that you can use to make sure that you are being more equitable and responsible. We just didn't cover it today just because it wasn't really within scope.
Thank you.
Good question, though.
Yeah.
Yeah.
And just one quick note on that. When you start to make these buckets of players, how you identify them isn't necessarily the end-all be-all of how you advertise or market to them. It really should just establish, like, here are the player delineations themselves. What's my strategy to approach them? So if it seems like they're low-value players, and this is where things like game data telemetry come into play, is it because of the experience that they're having? Is there something that we need to fix for them further upstream that's preventing them from being willing to spend on skin or whatever in-game offer you're interested in? So it's not necessarily that we want people to instantly give up on that user base. It's really just, hey, we've identified this because we have the data. Now let's take action on it. Fantastic. We'll be around to answer any other questions, but thank you so much for your time.
Yeah.